Welcome back to Math 124, Introduction to Statistics. Today we're going to be talking about Section 6.1, Hypothesis Testing for a Single Mean with Formulas. Here is a reminder about the steps we will take when performing hypothesis tests with theoretical formulas. First, we will formulate the hypotheses using the correct notation. In this case, we will be using mu, because we are going to infer something about the population mean. We will then calculate the test statistic using the correct formula. We will then use stat key to find the p-value, and finally we'll compare the p-value to the significance level to write or say our conclusion. Here we have a triple, but any of you who are familiar with triples will know that you never just have one triple. They multiply incredibly rapidly. Our continuing mission is to determine whether the mean number of triples produced each day by a triple is 165, or whether the triples have increased their powers of multiplication and they now produce more than 165 triples per day per triple. As I was explaining the situation to you, I almost completed identifying our null and alternative hypotheses. So there they are. The null hypothesis is that the mean number of triples produced by a day from a triple has not changed. It's still 165. On the other hand, our alternative hypothesis is that the mean has increased above 165. Now, we'll go into this more toward the end of the class, but triples increase, they multiply so rapidly, and they have such voracious appetites that any triple infestation is a problem. And any possible increase in their multiplication rate is an even bigger problem. So the science officer wanted to make sure not to miss any increase. Therefore, the significance level was set at 0.10. If you recall from our work with hypothesis testing using formulas for the proportion, we took the value that we received from a sample and compared it to the value identified in the null hypothesis. We will be performing the same type of analysis, but because we are working now with a mean, we're going to be using a t sub 0 instead of a z sub 0, because with means we work with t values. And we're going to take the mean of our sample, which I haven't given you yet, and subtract from it the mean of our null hypothesis. And then we will divide by the standard error, which is s divided by the square root of n. So a science officer gathered a sample of 30 triples and found that their mean reproductive rate per day was 172, with a standard deviation of 12. Let's calculate our t-value for this specific instance. We have the mean of our sample minus the mean in our null hypothesis divided by the standard deviation in our sample, which in turn is divided by the square root of n. So please remember that everything here is performed before it's divided into the numerator. At the bottom of your screen, you can see how that should go into your calculator. And if you have been doing this along with me, you will see that our t-value is 3.195, 0.48252, etc., but we are rounding to our thousandths place, 3 places to the right of the decimal. Here we have stat key. We are going to be looking down here at the theoretical distributions. We're going to be using the t distribution. We will need to enter our degrees of freedom, which will be 29, and hit return. This takes us straight to our t distribution. We are performing a right-tailed test, There we go. And we have to change our cutoff value to equal the t-value, our test value that we have here. That test value is 3.195. And now this is moved. See how very little area is under here? It's not probable that you'll be beyond that. This value is 0.0017. Let's compare that to our level of significance. The p-value is much less than our level of significance. This p-value would even have passed a zero point 0.01 level of significance. We must reject the null hypothesis. We have a problem. Tribbles are multiplying rapidly. Or, as the science officer reported, Captain, there is sufficient evidence at the alpha equals 0.01 level of significance to say that the mean number of tribbles produced per day per tribble is greater than 165. Let's look at an example for manufacturing now. Let's say we have this pipe, and in the interior diameter of the pipe, there is a little lip cut or a little bit taken out so that a washer will fit just exactly in that space with only a tiny bit of extra room around it. If that washer is cut too big, it's not even going to fit on that lip. It's not going to go down in there. It's just going to sit on top and be in the way of whatever connects to this pipe. On the other hand, if the washer is too small, this is a great exaggeration, but even if it's just a little bit too small, it could bend and disappear completely. So this washer is designed to be 2.6 centimeters in diameter. If it's too big or too small, it's not going to work. It is up to the quality control specialist to make sure that this plant is producing washers of the correct size to go into this position. If everything is as it should be, then her null hypothesis is that the mean diameter of these washers is going to be 2.6 centimeters. The alternative hypothesis is that, oh, there's something going wrong in the manufacturing process, and they are not 2.6 centimeters. Could be more, could be less. We don't know. That's why we're testing. Some of the machinery may need to be adjusted from time to time. To test the washers, the quality control specialist pulls 38 washers randomly selected from the line on a given day and measures their diameter. She finds that her sample of 38 has a mean diameter of 2.59 centimeters with a standard deviation of 0.03 centimeters. At first glance, it looks like the mean diameter of these washers is less than what it should be, and perhaps they need to shut down production and recalibrate some machinery, which is going to cost the company money. On the other hand, putting out a faulty product could also cost the company even more. So this is the dilemma that our quality control specialist faces. Here is the formula that we need since we are dealing with means. And here are the values we are working with substituted where they belong. The mean of the sample minus the mean expressed in our null hypothesis divided by the standard deviation of our sample here over the square root of the number in the sample. That is equal to negative 2.055 once we round to the thousandths place. Now we turn to our t-table courtesy of StatKey. We use the theoretical distribution, specifically t. However, our t-distribution does not immediately let us in. First, we have to provide the degrees of freedom, which is one less than the number of cases in our sample, in this case, washers. So put in 37 and hit enter. And we have a t-distribution. However, the cutoffs are not correct. These are not the cutoffs that we want. So we're going to enter our t-value, this time into the lower cutoff because we have a negative t-value. And if you are following along, you probably don't see those two tails yet unless you have first told StatKey that you want a two-tailed distribution, and then you'll see these two cutoffs. So click the leftmost cutoff and it will open up this custom cutoff box. You will need to enter our negative 2.055. Notice this is a two-tailed test. I put a little arrow up there to point it out again. And hit OK. Then here is the distribution we get. Always above our cutoff, we have a p-value. Is that strong evidence that the washers are too small or not the right size, at least because we're doing a two-tailed test? An inexperienced specialist might say, "Ooh, yeah, that's small. We have strong evidence that the washers are not the right size." However, this is a two-tailed test. We have to consider both of the areas to the left and to the right of our cutoff. So either multiply by 2 or add them up, and we get 0.046, which is not quite as strong evidence. I purposefully did not give you a significance level earlier because I want to discuss what some significance levels would mean. Now, often we go with a significance level of 0.05. It's pretty common. And in this case, there is evidence that the washers are the wrong size. But what if this company had had a major industrial accident occur because their washer was the wrong size? They might have started out not with that 0.05 level. They may have decided that they wanted to make it easier for their test to say that the washers weren't the right size. So starting with a higher significance level would mean very slight variations in the washers would be picked up and they would recalibrate the machines. On the other hand, if management is really concerned that it's going to cost them money if they shut down these machines again and again and again because the tests come back saying they need to do that, they might say, no, 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 we don't need to do that often. That's costing us money. Let's make the significance level smaller. So let's go with 0.03 as our significance level. Now, once again, if this were the set significance level, and if our specialist was not careful about what she was doing, she might look at this and say, oh, that's smaller than my 0.03 level. However, when she adds them up, as she needs to do because she's doing a two-tailed test, it is not smaller than the level of significance when it is set here. So it will depend upon what the company is looking for, what is significant to them. So let's return to where we were. Let's assume that the company did go with that 0.03 level of significance. Remember that our p-value was 0.046. Because our p-value is not smaller than our level of significance, we do not reject our null hypothesis. Do not reject it. So how would we say that formally? There is not enough evidence at the alpha equals 0.03 level of significance to say that the diameters of the washers produced on that date did not equal 2.6 centimeters because the test is only valid for that date. The machines have wear and tear on them every single day. If the random sample is not from multiple days, it can only represent the day on which it was taken. Well, may your washers always be the right size, and may your triples be non-existent. I will see you in class.